about atomic radius yesterday. We talked about periodicity yesterday. Okay. If you look into the periodic table, you will see that periodic table is classified into 4 blocks here. From the configuration, you can talk about that, and those 4 blocks are the S block, this one, the D block, the P block, and the F block. Okay, these are the blocks in the periodic table. So this is the specification actually. I'll be sharing with you the specification as well. Okay, so you need to be knowing the specification also. Before going into many other details, let me show you the specification first. Okay, for unit 1, let me show you the specification. This is your unit 1. Okay, formula and equation is already done, the first chapter. Now atomic structure we are working on. Structure of an atom in terms of electrons, protons. We have done this part. Know the relative mass and charge of proton, neutrons, and electrons. Already talked about it. Atomic proton number, mass number. Can someone tell me what is the mass number?
So the total number of neutrons and protons in a nucleus.
Okay, atomic number is only protons and mass number is the number of protons plus neutrons. Okay, be able to use the atomic number and the mass number to determine the number of each type of subatomic particles. Just simple grade 10 calculations are there. Okay, sodium is having 23 and 11, or in some of the periodic table it's 11, 23. This is the atomic mass. Okay, and this is the atomic number. Okay, the bigger value is always the mass, the smaller value is always the number. So 23 minus 11, 11 are protons. Keep in mind, protons are always equal to electrons when the atom is neutral. And when you subtract this value, you get a result which is almost 12. These are the neutrons. Okay, are we clear?
Yes.
Okay, what are
Yes, sir.
isotopes? Isotopes are the atoms of the same element. Atoms of the same element having same number of protons but different number of neutrons. Isotopes are the atoms of the same element having same number of protons but different numbers of neutrons. Okay, understand the basic principle of mass spectrum and be able to analyze infrared mass spectra. This is also very important now. Okay, deduce the isotopic composition of a sample of an element. We talked about chlorine, Cl35, and Cl37 and 35. Calculate the relative atomic mass of element from relative abundance of isotope and vice versa. We did this calculation. Cl35 was how much? 25%. And Cl37 is how much? 75%. So 35 times 25 plus 37 times 75 divided by 100, you get the answer to be 35.5. This is how the relative atomic mass is calculated. Okay. Determine the relative molecular mass of a molecule and hence identify molecules in a sample. So we were working on Cl2. Cl2 was of two types. One was 35, 37. The other was Cl35, 35, and the other was Cl 37 and Cl37, and we were doing the height of the peaks. We were taking Cl37 and Cl35 as well. So these two were similar. Okay. And if the ions are having 2 plus charge on it, the x-axis is giving you m mass to charge ratio, m by z. Okay. So then if there is a 2 plus charge on it, copper is usually take any of the element, okay, not copper, take chlorine, Cl with 2 plus charge. So if I take Cl35 with 2 plus charge, I'll divide 35 by 2 and I'll get 17.5 for it. So when I'm getting the peak, I will get a peak somewhere else. I will be getting normal peak at 35, another peak at 37, and I'll get one peak here in the same sample, which will be 17.5 or 18. So what will I think about it? It's chlorine, Cl, it's 35, but the charge is 2 plus. Okay, are we clear?
Yes, sir.
Okay, so moving forward, understand the ions in a mass spectrum, explain this one. Be able to predict mass spectra including relative peak heights. We discussed that for diatomic molecules including chlorine, given the isotopic abundance. We discussed this part. Okay, but if you want to know about it a little bit more, I will show you this now. We discussed about this part, chlorine also. We talked about it. Okay, this is the part which I was talking right now to you. This is C, molecular region, and a molecular region. So you got three molecular regions here. Okay. Even they can ask you the most common example, another one. They will ask you about bromine. Bromine is having two isotopes, 81 at 79. Okay. Now you can see you can get two of the top isotopes, 79, 81, and then 81, 79. And this one, 81, 81. Keep this in your mind that these two isotopes of bromine are having 50-50 ratio. Okay, 50-50 means 1 by 2. So when I'm working on these heights, these two heights, we are 79 and 79, 1 by 2 times 1 by 2. How much I'm getting? 1 by 4. For this one also, I'm getting 1 by 4. And for this, how much I'm getting? Half times half. 1 by 4 is for first one, and then 1 by 4 is for another one. Okay, 1 by 4 as well. So the central one which I'm getting is 1 by 4 plus 1 by 4. How much is this? 2 by 4.
So 1 by 2.
And it will be 1 by 2. Okay. So 1 by 4 is a smaller quantity and 1 by 2 is a bigger quantity. And as compared to this value, 1 by 4, this is double of this because we took 2 by 4, 2 1 by 4. So that's why you can see the relative height. So the relative height for chlorine, for bromine is, for this one is 50% and 50% higher than this one. If this is 50, then this one is double of 50. So what am I getting? I'm getting 100 for this and 50 for these two. If this one is 25 and this one is 25, then this one should be 50. This is how we are considering the height. Okay? Any question?
Okay, sir.
Okay, you can see there's a molecular ion peak also. You can see here molecular ion peak stands for the mass of the whole molecule. Now see here CH4. If it's a molecular ion peak, the whole molecule it's representing C4H. So 12 times 4 plus 1 hydrogen. It's 49 somewhere. Is it 49? Because this peak seems to be different. Okay, see the molecule. The molecule is C4H10. So C4 is 41 and 10 is this. So we are getting 50, 58 exactly. So at 58 we are getting this is the molecular peak. So it is actually C4H C4H10. Let me correct it. Okay, there is a mistake in it for the molecular peak. Uh, it's H10. Okay. Okay. So C410 with plus charge on it is the molecular peak. Okay. Plus one charge is there on it. Okay. Now the specification is telling be able to define first, second, and third ionization energies and understand that all ionization energies are endothermic. So to give you the equation for first, second, and third ionization energy, aluminium is losing one electron minus one and it's changing into aluminium plus one. This is the equation for the first ionization energy. Then aluminium with plus one charge is losing another electron, changing into Al2 plus with gaseous state and gaseous state. This is the equation for the second ionization energy. And then aluminium is losing another electron. Okay, minus one electron, and you get Al with 3 plus charge and gaseous state. Okay, this negative electron can be added on the other side as well. Okay, if you're not writing it here, then you can add it to this side as well. G. Okay. Now, how I'm going to define it, I told you all the definitions are for 1 mole and under STP. Standard temperature and pressure, where temperature is 298 Kelvin and pressure is 1 atm, which is 100 kPa kilopascal. Right? Any question till now?
No, sir.
Okay. So moving a little bit forward now, the definition of ionization energy will be it is the enthalpy change when 1 mole of a gaseous atom releases 1 mole of electrons making 1 mole of gaseous cation. For the second ionization energy, the enthalpy change when 1 mole of a gaseous 2 plus cation releases 1 mole of electrons, changing into 1 mole, this is 1 plus, sorry, changing into 1 mole of 2 plus cation. Then third ionization energy, the enthalpy change when 1 mole of 2 plus cation is releasing 1 mole of electron, changing into 1 mole of gaseous 3 plus cation. All the definitions will end up with STP. S, T and P. Are we clear with this?
Yes, sir.
Okay. So moving on, keep in mind the class lecture will be uploaded on YouTube, so you can download it or you can watch it there then later on. If you miss anything and you don't understand, keep watching them. You can watch it any other time also. Okay. Be able to define first, second, third ionization energy is done. Know that an orbital is a region within an atom that could hold up to 2 electrons with opposite spin. We talked about the shape of the orbitals S, P and D and F, where S spherical, P is principal, D is for diffused and F is for fundamental. So spherical, these are the names. Principal, diffused and fundamental. Okay. Now S is of one kind, it can accommodate only 2 electrons. P is of 3 kinds, every kind can accommodate 2 electrons, so total 6 now, total 2 now. D is of 5 kinds, every kind can accommodate 2, so total electrons are 10. And F is of 7 kinds, can accommodate 14. Right? I want it to be related to the uh, shape of the periodic table now. You can see the periodic table here. S is of 2 kinds. So you can see S has 2 kinds here, 1 and 2. 1s1, this one end up with 1s1. Okay. This one end up with 1s1 or S1 only. Then this one will be 1s1. This will be 2s1. This will be 3s1. This will be 4s1. Okay. This one is S2. So 2s2 because 1s is not having any second one. This is D block. So we have D1, D 2 electrons, D 3 electrons, D 4 electrons, D 5 electrons, D 6 electrons, 7 electrons, 8 electrons, 9 electrons and 10 electrons. This is D. After D we have P. How many are they in number? Total 6 electrons can be accommodated. So P having 1 electron, P is having 2 electrons, P is having 3 electrons, 4 electrons, 5 electrons and P6 completed. Now if we focus on D block, D is F block, F is 14 in number, total 14 electrons. So we need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 11, 12, 13 and 14. So total 14 small columns are there in it. So F1, F2, F3, F4, F5, F6 and 7. I'm talking about the number of electrons. Okay. There are total 7 kinds of F and each one can accommodate 2 electrons in it. Any question related to this?
No, sir.
No, sir.
Okay, be able to describe the shape of S and P orbitals. We already talked about S and P orbitals. Okay, S was spherical in nature and P was dumbbell in nature. Okay. Know that the orbital in subshells each take a single electron before pairing up. There were rules which I explained to you, the Hans rule and the Pauling exclusion principle. Pair up with 2 electrons of an opposite spin. So rule number 1 was that they will be living independently. And rule number 2 was that you can then pair up with opposite spin. Okay. Moving on to be able to predict the electronic configuration of atoms of an element from hydrogen to krypton, inclusive of their ions. So we talked about inclusive of their ions. You should be able to do the ionic configuration also, and you can do in box notations. Okay, and you can simply do 1s2, 2s2, 2p6, but the same one you can do in the box notation if there are 3 electrons in it. But boxes should be like this is S1, this is S2, and 3 should be, they should be higher a little bit, okay, from each other. This is how they're going to be dealt. Okay. Any question till now? Understand that electronic configuration determines the chemical properties of an element. Okay, chemical properties can be predicted from the outermost electronic configuration. Let's suppose 1s2 and 1s1 we are comparing. Which one is more reactive? 1s1 is more reactive than 1s2. The reason is this is completely filled and this one is partially filled. So completely filled is unstable, completely filled is stable and partially filled is unstable. Know that the periodic table is divided into blocks such as SPD we discussed right now, the SPD and SP blocks right now we discussed that. Be able to represent data in a graphical form including the use of logarithms of first ionization energies. We discussed this information, the first ionization energy information yesterday, and I'm giving you again this information. The graphical representation was here. I've explained that to you yesterday, okay? Why there's a fall and why there's a fall. These 2 falls were explained and it is uploaded on the YouTube channel. Please check that out. Be able to explain the trends in melting and boiling temperature. Already explained the trend in melting and boiling temperature to you from the book, and this is also uploaded on the YouTube, okay? So check that out also. The journey increase and the specific trend in ionization energy, we talked about it across the period and down the group, ionization energy, and we talked about the effective nuclear charge, okay, and we talked about the shielding effect, we talked about the atomic radius as well in detail. Now I'm picking up any question. If you have, just ask me the question. Do you have any question? Any question, please?
No, sir.
Are you sure that you don't have any question?
For timing, no.